Okay, Papa, you're talking about this where gemstones form.
Gems can be formed in different level of the Earth's structure. Okay, it can be formed at the upper mantle regions or even lower mantle regions. And the mantle regions, of course, like peridot, for example, is formed at the very deep, about nearly 700 kilometer depth area. You see,
Here, lah,
yeah,
on the upper mantle, lah,
upper or
or the
even
lower.
low mantle region, and
Okay.
then this peridot, for example, eventually brought to the surface by volcanic eruptions. Okay, and other than that, also diamonds also believed to have formed about nearly 600 kilometers. In the old days, it used to say about 200 kilometer depth, but now the scientists have discovered that based on the inclusion study, some of these diamonds are actually formed about 600 kilometers depth.
So it's the upper mantle, lah,
Yeah,
not the lower mantle.
It can be upper. You do not know, you see.
Still
Now,
question mark.
in the old days, you used to say that what 150 to 200 kilometer depth.
Yeah.
But then realized that only last 2 years ago they discovered that some of the inclusion can be as deep as 600 kilometer depth. So the possibility of upper mantle region they are formed, and then eventually extrude out through volcanic eruption. So diamond is one of the occurrence that is found through the volcanic kimberlite rocks, due to volcanic eruptions. And of course, diamond formed from this kimberlite doesn't mean that all the kimberlite will have diamonds. It's only in certain locality when they have the presence of such a diamond occurrence, then of course you may have 1,000 diamond pipes, but maybe less than 10% may have diamonds.
So what makes diamond form at that particular? What are some basic conditions?
Scientists believe that there is a reservoir. There's a reservoir of presence of a pool of carbon that is present at high pressure and at high temperature, and that's how scientists discovered and postulated that it could be due to the presence of this reservoir.
Hydrothermal. Is it?
No, not hydrothermal. It's a reservoir of this
a pool
magma,
of that.
magma. Within this magma, there's a
lot of carbon.
There's a presence of carbon, high temperature, high pressure carbon, you see. And of course, diamond is one of them. And as a result of that, through volcanic eruption, materials are brought to the surface, and the rocks that they discover was the geologists call it kimberlite, and this is what happened. The word kimberlite attached with diamonds. Okay.
So, in summary, for this whole picture,
so you have
the lower
the cross section. This is a cross section of the oceanic crust and continental crust. Continental crust is on the right hand side. Oceanic crust on the left hand side. Okay. And within this crust itself, there's constant movement and things like that. There's the mantle magma itself is the upper mantle region. There's constant movement of this magma. Okay. And the formation of mineral itself, okay, so it could be found in the lower or even upper mantle region. And upper mantle region, you can discover they have found olivines, or which is called a peridot for our gem people. You can have garnets, for example, and it's been formed at great depth, and eventually, like diamonds, the same thing is brought up through the volcanic eruptions. And you can find some of this volcanic eruption material like rubies and sapphires in Thailand, for example. Even Australia is another example. And of course, the other example, good example, is presence of diamonds in the pipes. Volcanic pipe is in South Africa, in Kimberley. Okay, and then the other one, of course, in China, they have this Menging. In Shandong province, they have diamond volcanic pipes. The same thing with Mir, which is MIR, Russian. In the Yakutia region, they have their volcanic pipes too. So that is one formations. And of course, once the volcanic eruption erupt through the surface, and through millions of years of erosions, materials are broke away from the volcanoes and then eventually worn down. Many of these materials are transported by water in, or even by wind,
glacier,
or glacier also, and eventually transport to the lower valley areas to form sedimentary rocks. And that's how people discover diamonds or even gemstones in the alluvial deposit area. You see, so there's actually a cycle of these materials. coming out from the depth of the earth, volcanic eruption, eroded, and the materials are eventually eroded and then transported away from the source and then form as alluvial deposits, along the valleys or even crevices in potholes and things like that in the sedimentary, or even along the beaches. There are some of the beaches in Sri Lanka, for example, you can find garnet beach, the sand that we had, Tangala, the area, and the whole beach is actually very fine sand, garnet sand. And some places you may have sand of peridot sand.
Amazing.
I went to one in Zhangjiakou in northwest of Beijing itself. The mountains is volcanic mountains, very basaltic, and there's a lot of peridot been discovered there. Breakdown of this peridot from huge boulder into nodules, into smaller stuff, eventually form into sand. So the whole sand is all made of peridot.
Wow.
Peridot sand.
Awesome.
The peridot.
Yeah.
Small.
That one you pick it up from there.
Yeah, pick it up from there.
Okay, so in summary, this whole picture, it just talk about the whole
cycle,
and the space, the place where the gemstones occur, and also talk a little bit.
It's not just 1-2 kilometers. Sometimes it be hundreds of kilometers. In the depth itself is a couple of 100 kilometers. On the surface of the land, on the Earth's crust itself, continental crust, you may have formed, which is tremendous.
So in the Earth crust, normally gemstones start forming at the crust, right?
There is possible that gems form in the Earth crust itself by magma. Just now earlier I mentioned, the magma intrude into the continental crust. Okay?
Yes.
So once it intrude the continental crust, this magma is act as a heat sink. So this heat itself will hit the surrounding rock. Okay, so baking the surrounding rocks, and in doing so, when they bake the surrounding rocks, if you are present aluminum with present oxygen, they form into
at the crust,
at the crust region, they form into rubies and sapphires for that matter. And then a good example is Mogok itself. Very good example is spinel. Spinel are the earlier formations present of the magnesium in the soil. So first formation is the magnesium take out from formation of spinel. So when you take out all the magnesium away, what happens? You left with aluminum oxygen. You form the rubies and sapphires. So of course the color of rubies is caused by the presence of chromium. The color of sapphires, blue sapphire, is present of titanium and iron charge transfer. And because of this, rubies and sapphires can be found even in Burma. Okay, so imagine you are Thailand, you have the volcanic eruption that rubies and sapphire form in the depth of the surface of the earth itself, and then eventually brought to the surface. Whereas in Mogok itself, the rubies and sapphires are formed by the intrusion of the magma into the earth crust itself, and then surrounding rocks are heated up, and then present aluminum, oxygens, or even if you have magnesium, then of course it forms into spinel. Then if it's aluminum oxide itself, it forms into rubies and sapphire for that matter. See, so you have a composition of the igneous body. You see.
Okay.
I want to draw the diagram for you.
Okay, let me stop.